In this lesson, we're going to use the scalar product to find the angle between two vectors. So far we've used these two formulas that are on the screen, that are both in the formula sheet. We've got a dot b is equal to a1b1 plus a2b2 plus a3b3, the component form of the scalar product. And we've got a dot b equals the magnitude of a times the magnitude of b times cos of theta. So what we're trying to do really is get this angle here. And to do that, it's really easy to rearrange this formula. The formula that I'm going to rearrange is not given in the exam, but if you think about the magnitude of A and the magnitude of B, this part here, really what you do is you need to divide this side by that to get cos theta. And that's all you do. Cos theta is equal to A dot B all over magnitude of A times the magnitude of B. Or it could be written like this, with the component form of A dot B over magnitude of A times magnitude of B. But this is the formula here that I would recommend you try and remember. It comes up lots, it's worth a good number of marks, and it's quite often the exam questions. I think it's 5 marks or roughly there. So you need to memorise that, and the way to do it is just to kind of think about this formula in the formula sheet and think, I need to divide by that to get cos theta. So let's look at an example of how to do that. So calculate the angle between the vectors p equals 3i plus 4j minus 2k and q equals 4i plus j plus 3k. So you go to the formula sheet and you would create this formula. This wouldn't be given, but you'd have to create it. And then you would start thinking about what you're going to work with. So you have to get the top line, p dot q, and then you have to get the magnitudes of the two and multiply them together. So this is the angle we're trying to find. Let's do p dot q first. So if p in component form is 3, 4, negative 2, and q in component form is 4, 1 and 3, because there's no number there, so that's just a 1. So I can get p dot q if I times 3 by 4, and then do 4 times 1 and add it, and then negative 2 times 3 and add it. So that's going to become 12 plus 4, which is 16, take away 6 is 10. I can then work out the bottom bits, the magnitude of p. So the magnitude of p is, you square these numbers and add them, and then square root. So square root of 3 squared plus 4 squared plus negative 2 squared. And that works out to be root 29. You're going to get a 9 plus 16 plus 4. And then do the same to q, magnitude of q. Square root of 4 squared plus 1 squared plus 3 squared. So what's that? 16 plus 1, so that's 17 plus 9. That's 26. And finally we have to take all the information we've calculated. The stuff we're looking at is this 10 and these two roots. And we're going to feed them into this formula. We've worked out the top bit's 10, and that's root 29 and root 26. So feed them in, 10, root 29 and root 26. And then to work out theta, you have to inverse cos all of this. Do the inverse operation, so 10 over root 29 and root 26. And if you put that into your calculator, you get 68.6. Now you really need to practice putting that into your calculator, an inverse cos, and some people struggle with that. What you can do is you can work out the bottom line. You could do root 29 times root 26 and work that out, and then do 10 divided by that and use your ANS button. You could do 10 divided by and then brackets and then that, and then inverse cos it. Or you can put it all in at once into your calculator if you know how to do that. It's inverse cos and then bracket, and then 10 divided by this, and then close your brackets, so you have 2 sets of brackets there. But practice this, and if you don't know how to do it, come and ask me and I'll show you how to do it.